Hello, for this part of the tutorial I'll be looking briefly at what is machine ethics and various classifications and terminology that surround the field. This is really to help us frame the discussion for the rest of the tutorial. So our key question that seeks to be answered by machine ethics is how to automate moral reasoning. Obviously the field of AI and ethics more generally is much wider than that, but in what we commonly call machine ethics in academia, that is our key question. So obviously there's been interested in this going back for almost as long as there have been computers, but the real upsurge in interest can be traced back to the turn of this century, certainly around kind of 2005, 2006. So in a 2006 paper, James Moore defined 4 sorts of ethical agent. So an ethical impact agent is one that may not actually be specifically reasoning in an ethical way, or whose reasoning may not be about ethics, but its simple deployment has an ethical impact. So you can imagine a whole load of computational systems, for instance, that are employed to improve safety, provide cut-offs in particular situations, and they don't really reason or have autonomy in the ways we tend to use them in artificial intelligence, but they do nevertheless have an ethical impact. Then we have what we call implicit ethical agents. So these are ones where, we believe they are some kind of AI system, we believe they are making decisions about something, we might believe they have some kind of level of autonomy. I mean, obviously all of these things are quite fuzzy terms, but what we think is that when we look at how they perform their reasoning, they are not internally using concepts of, is this the right thing to do? The reason their decisions and choices are ethical are because of the software engineering and the design that has gone into creating them that has constrained their ability to do things within some kind of ethical area. So building implicit ethical agents involves a lot of good software engineering practice, and a lot of the emerging field we have in AI and ethics is about how to design implicitly ethical agents to make sure that what your computational system does will be ethical, the choices it makes will be ethical, but you don't expect the system itself to be using concepts of right and wrong in the way it reasons. When we come to explicit ethical agents, then we say that these ones do somehow use some kind of concept of right and wrong within their reasoning. And the kind of classic case of this is where someone has taken an ethical theory from philosophy and attempted to implement it as a reasoning process. And then we can see that the agent is making its choices in accordance with that philosophical theory. But I think there is a kind of wider field around here where you can see that there is some kind of concept of right and wrong embedded in the way the agent actually does its computations. And lastly, what we have are full ethical agents, and we don't really know how to build these, but we consider humans to be fully ethically agents. So they are not, the ethical decision making isn't constrained by their coding in some way. They are genuine moral agents, and they can genuinely make moral decisions, not necessarily within a philosophical theory, but they have concepts of right and wrong that they have got from somewhere, possibly society, possibly from first principles, and those concepts of right and wrong guide the way they make their choices, and they may not always make the right choice. So another categorization of machine ethics is the distinction between functional and operational. And this models quite closely that transition from kind of implicitly ethical through explicitly ethical through to fully moral agents. And this comes from Wallach and Allen's book, Moral Machines. So the idea is that you have operational morality, which is in some sense just comes from the way the system has been coded up. And insofar as there is any ethical agency there, that resides in the programmers of the system. And then we move into functional morality, where the system has some concept of ethical reasoning itself, and so does make choices with explicit reference to some concept of ethical reasoning, through to full moral agency, where the system is free to act either in the way it believes to be right or in the way it believes to be wrong, and this is not somehow dependent on some external coding. Another distinction, which also comes from the Moral Machines books, is the difference between top-down and bottom-up implementations of machine ethics. So these concepts go back into the theories of the design of computational systems, and even further back into just kind of general problem solving. So you approach a problem top-down by dividing it into sub-problems, and then tackling each sub-problem in turn, possibly dividing each sub-problem until you find a solution. In the design of a computational system, you start with a high-level architecture, you divide things up into modules and subsystems, you apply design to those modules and subsystems, and so on till you actually get down to the coding stage. So in machine ethics, a kind of classic top-down approach would be to say, well, we take an ethical theory and we try and work out how to implement that ethical theory, and then we try and work out how we gain the information we need in order to actually reason with that ethical theory. So you're kind of a decompositional approach where you start up with a philosophical theory. If a problem is approached bottom up, then in the design terms, you start by designing your subsystems, and then you assume that you'll somehow manage to put all these things together in a way that works. In terms of problem solving, it can just say, well, you can identify sub-problems that you're probably going to need to solve, and you start with them. But it can also involve, as it were, describing the solution and then having automated techniques that will help you solve it. And obviously, a top-down approach gives you a very clear structure what you're trying to do and avoids you doing lots of unnecessary work, or at least that's the theory, solving problems you don't need to. The problem with the top-down approach is that you can bake in at the high-level decisions, which when you actually get to trying to implement a candidate solution, realise don't work at the bottom level. Whereas obviously if you have a bottom-up approach, you start from producing things that actually work, defining problems, solutions to problems, and then that way you've actually got realistic systems when you try and put them together. In machine ethics, a bottom-up approach is often used to refer to approaches where you are trying to learn ethical behaviour from data. So you have some data set in which you somehow manage to annotate things as right or wrong, or you're simply going to observe from what people do and assume that people do the right thing and don't do the wrong thing, and try and infer what is right and wrong and how you're supposed to behave correctly from that data set. I'm actually adding a further category here, and I've chosen to call them constraint-based ethical systems versus global ethical systems. And when we come to look at implementations, the very first implementations of ethical reasoning was an ethical governance system, and the idea was it was vetoing and guiding choices from some underlying system. So in a constraint-based ethical system, you are assuming that not all system reasoning involves ethics. So the ethics is some subsystem that guides or constrains the actions of the rest of the system. And obviously there's a variety of the ways the ethical system may interact with what's going on elsewhere, but the point is that not all reasoning that happens is ethical. There are other things that are guiding the reasoning in the system. In global ethical systems, the assumption that all reasoning is ethical reasoning. There's no way you can distinguish between a choice that involves some other factors, like what you're trying to achieve, from the choices that are about what you should and should not do. And that can often involve things like achieving the system goals as an ethical thing to do, alongside other ethical considerations you may have. But the idea that the whole system reasons with ethics all the time, and there's never some suggestion of one part of the system suggesting some things it would like to do, and then another part of the system interacting with those suggestions and guiding or constraining them. Everything is an ethical decision, everything you do has ethical impact, and ethics has to guide every single choice made within the system. I think you've probably already seen from the way I'm struggling to define some of these things that taxonomies are hard. And I think it's important to realise that all these categorisations are about features that may be held by a particular system. And when you actually get into the details of what a system is doing, it can become quite fuzzy around the edges. So I think these are all useful ways to think about machine ethics systems and useful ways to think about what the designers and implementers are trying to achieve. But you shouldn't think of them as things with rigid boundaries, that some system is definitely in one of these categories, it's definitely an implicit ethical agent, or it's definitely an explicit ethical agent. But just be aware that it may have some implicit features, some explicit features. And, you know, for instance, when I'm trying to distinguish between implicit and explicit ethical agents, I'm saying that the system explicitly considers the question of right or wrong. Well, what does that mean? What does it mean if you can't see the program code? I mean, maybe if you can see the program code, the program is helpfully put in a comment which says, this is where we decide what's right or wrong. But that's not necessarily the case. It may not be the case in a machine learning system. Are machine learning systems doomed to be implicitly ethical? I don't think so, but it can get quite difficult to figure out how these things actually apply to an individual system. I've not really talked about the philosophical theories that Maria was looking at, but we get that in the same way with, is something a virtue ethics system, a deontological system, or a consequentialist system? For instance, lots of deontological theories involve reasoning about the intentions of an agent when taking an action. Well, your intentions sort of get you into this values field where we tend to be thinking we're talking about virtue ethics. So although something may be described in the literature as a deontological theory, it may have a lot of features that we think hold for virtue ethics theory. So again, these are useful ways to think about things, but they aren't necessarily useful if you're trying to assume these are mutually exclusive categories and everything must fit into exactly one of them and not in any of the others. And similarly, I was saying that we tend to say that a bottom-up system is one that's using a machine learning approach, but what if there was a top-down design of the reward function because you were trying to capture some quite specific ethical outcomes and you had to think your way through them? Is that then a top-down or a bottom-up approach? So I think these are all really useful ways of thinking about machine ethics system, but I don't think yet the field has really got some clear taxonomies where you can easily slot any system you come across into one of these places in the taxonomy.